Okay, thank you very much for the introduction. So my name is Xingchen Zhang. I'm from University of Exeter. So today I'm going to talk about protecting pedestrian privacy through face swapping. So as you know, nowadays people, have captured and is capturing many computer vision data sets. So I'm listing six very widely used data sets here for different tasks. For example, autonomous driving, pedestrian intention prediction, and also the pedestrian detection, crowd counting, multiple object tracking, and semantic segmentation. So there's one issue in this data set is that, the faces of pedestrians are visible. So from all these six data sets, we can clearly see the faces of pedestrians. So actually this introduced a privacy issue. And recently in Nature, there were two articles talking about this computer vision, the privacy issue in computer vision research. They basically mentioned more than 90% of computer vision research are related to surveillance, which is actually a very important and very urgent, can cause very, serious privacy issue. So it is essential actually to protect privacy of pedestrians when capturing the pedestrian data sets. Traditionally, if we have this pedestrian image, the traditional method to do the anonymization is to blurring the face or put some mask here. But there is another problem of this traditional method is that by doing this, basically, we can protect privacy, but the anonymized data is not very useful for some computer vision tasks. For example, previously I worked on project to predict pedestrian intention, crossing intention. In that application, the head pose and the eye gaze of pedestrians are very important. But if we do this kind of blurring, then the data basically is not very useful for training and testing the model. So based on this motivation, actually we propose our method based on face swapping. So our main motivation is to, firstly, we want to anonymize the pedestrian data. And secondly, we hope that anonymized data can be useful for our model training and test. So the basic idea is that we propose a face swapping model. So this is the original image, and we build a source image library. So basically, we select one face from this source image library, and we do the face swapping. So basically, this is the anonymized data. So the identity of this pedestrian and this one are different because we do the face swapping. So I have some results to show. So firstly, the similarity rate between this face and this face is quite low, which means the identity is different. And also, in this image, we can still detect the face in the anonymized data. So which means the face detection algorithm still works for the anonymized data. So in this way, actually, we can use this data to in computer vision tasks. This is the basic framework of our method. So basically, we firstly do the pedestrian detection, and then we do a face detection, and we crop the face and do some pre-processing to improve the image quality, and then we propose a source face selection algorithm to select the source face from our library based on the attribute of this face, and then we do a face swapping, and then we combine the swapped face and the original image to have our final output. A very important thing in our method is the source image library. It is well known that if we use GAN or diffusion model to generate the fake faces, there might be some copyright issues because the training data, many of the training data actually is copyrighted data. So we hope to avoid this kind of issue. This is why we actually we bought some real face from this website with license. So we use this real face with license to build our source image library. In this case, we avoid the copyright issue. So basically, we pay, for example, £100 to buy 50 faces from this website, and we have the license to use them. And as you can see in the library, we have different gender, we have different age groups. So this is to make sure the swapped face has similar attributes to the original pedestrian. And after we have the have built the source face. As I mentioned, we propose a source face image selection algorithm. So the idea is that we hope that the swapped face has similar age and similar gender compared to the original pedestrian. So this is why we firstly do an attribute recognition for the original face to have the gender and the age group, and then we select the same age group and the same gender from our source face library, and then we have another comparison method to select the final face from these 3 candidates. So in this way, we can make sure the final choice actually it has the same gender, has the similar age group compared to the original face. Another very important thing is that we not only want to apply our method to images, we also want to apply our method to videos. So in this case, it is very important to maintain the temporal consistency in the anonymized video. So we propose another method, algorithm in our method to make sure the temporal consistency is good. So the basic idea is that we combine our method with a multiple object tracking method. So in this way, every pedestrian will have a unique ID provided by the multiple tracking algorithm. And also, we use a counter to count how many times, each source face has been selected from the frame 1 to the current frame. And then we always select the highest counter as our choice. Because the reason of doing this is because when we do the attribute recognition for the original face, because as you can see, the resolution is not very good, and also because there's some movement of the pedestrian. So sometimes the attribute recognition is not very stable. As you can see, for the same pedestrian, actually in different frames, we may recognize they have different age and different gender. So basically, which is not very stable. But by using our this counter and this algorithm, we can make sure we select the same source face for the swapping. So in this way, actually, we can make sure the face swapping in the whole video is consistent. We try to use an existing face swapping model, but we tried that. We found that it's not very, the performance is not good if we use an existing face swapping model, because most of the face swapping models are proposed for very clear, very high resolution images, faces, not for the pedestrian image. So we modified existing face swapping model by propose a pose loss to make sure the swapped face, swapped pedestrian and the original pedestrian have the same, have similar head pose. This is the new Nostrom proposal in our work. So basically, we use 6 landmarks on the face to make sure we have the anonymized video face and the original face have similar pose. And also we found that there's an issue in this pedestrian anonymization work is that there was no benchmark in this field. So we proposed a dataset based on a commonly used open source dataset, the JAD dataset. And also we proposed 4 types of evaluation metrics to evaluate the performance. So we, as I mentioned, we not only want to protect privacy, we also hope that the anonymized data is useful. So we also use some propose some application metrics to test whether the anonymized data is useful or not. So this is why we propose a pedestrian detection related matrix, and also we propose an attributes reusability matrix. So these two types of matrix are used to evaluate the utility of the anonymized data. And this type of privacy protection is used to evaluate the privacy protection performance. So this is our results. So basically, if you see the first part of the table, as you can see, our method actually has the best performance in most of the matrix, especially for the pedestrian detection related matrix and for the attribute reusability matrix. Our method actually has the best performance compared to a state-of-the-art count process. Here are more visualizations of the comparison between our method and the existing method. So the second column is our results. So as you can see, compared to this is called this method is deep privacy. This is deep privacy 2. So compared to all this method, actually the swapped pedestrian provided by our method actually is more realistic. And here we show the result in a video. So the second column is our results across different frames. So as you can see, our results are more consistent compared to other methods. We also have some real demos. So actually, we actually conducted this work at Imperial College. So we captured some videos using a robot wheelchair, and then we run our methods to anonymize this video. This is the result. So this is me. We capture the original video, and we do the face swapping. So as you can see from the zoomed-in result, actually, the face is different. And we do more tests. So the similarity rate between my original face and the swapped face is very low. And the similarity between the swapped face and the source face is quite high because we select this guy, the face of this guy, to do the face swapping. We also do some experiments at University of Exeter. So we use a robot dog to capture the videos for my students and my colleague. The result is here. So when my student is running, actually, we can do face swapping. If you see carefully, you will find the face of my student is different. Of course, we have the zoomed-in picture here. If you compare the two faces, you will find they are different. And here's another frame. We also tested our method on some public data sets, as I mentioned, the JAD. So the left frame is the original image. The right frame is the right image is the anonymized data. So if we compare the face similarity between this one and this one, you will see the similarity is quite low, and the same. The same here on the bottom frame. So in conclusion, privacy issue is a critical issue in AI and computer vision, as mentioned by the very new Nature paper. And we also found the privacy issue in many common open source data sets. And so in this work, we propose a face swapping based method to anonymize the pedestrian. And at the same time, we maintain the utility of the anonymized data. So this work was conducted by my student and also supported by my previous supervisor at Imperial College. So thank you very much. Thank you. Any questions?